Alright guys, so video notes, week 3 Thursday. This is going to be kind of an extension on Tuesday. We're still adding and subtracting rationals, but now we're dealing with things that do not have common denominators, right? As you can see from that very first one. Still the same concept, still going to be the same kind of process, except we're just going to add one thing before it. We got to get those denominators to be the same, right? That's all we've got to do. Nothing really changes dramatically or anything like that. But let's kind of dive in here. Okay, so number one, 8 over 3x plus 5 over 4x. Well, we need the least common multiple is what we ended up stopping with at the end of the last video, numbers 4 and 5, right? We need the least common multiple of things. That's all we're doing here, guys. So in this case, 3x and 4x, those least common multiples, right? We can sit here and list, right? We can sit here and list. So what is the list of multiples of 3x? Well, we can multiply it by 2 to get 6x, or 9x, or 12x, or 15x, right? We can do that. And then the multiples of 4x, we can do the same thing. So 4x times 2 would be 8x, times 3 would be 12x, times 4 would be 16x, and 5 would be 20x, right? So the same things. Which one's the least common one? Well, that would be this 12x right here. Right? So this least common multiple is 12x. What do we multiply 4 by? Well, we multiply 4 by 3, and we multiply 3 by 4. Right? All that's great. So in order to do that, we got to multiply the top and the bottom. So I've got to multiply this whole fraction times 4 in order to get the denominator being 12x. So 8 over 3x times 4 over 4. Right? Got to multiply them both by 4. So that's going to be 32 over 12x. And remember, guys, multiplying by 4 over 4 is just fine. We can do that because 4 over 4 is just 1. So we're not affecting the value of this fraction. We're just kind of making it a little bit more convenient for us. So same thing over here. This 5 over 4x, we've got to multiply that whole fraction by 3 over 3. Right? By 3 over 3. So 5 over 4x times 3 over 3, that's going to give us 15 over 12x. Right? 15 over 12x. So now we can bring these new guys, right? We can say, okay, well, what is going to be 32 over 12x, 15 over 12x? Right? This is this guy. And the blue one is this guy. Right? What is that going to equal? Right? So, again, guys, now we've got this denominators being the same. Check and check. Right? 12x is equal to 12x. Right? No big deal there. So, once we have that, we can just affect the numerators. So, 32 plus 15 is going to be 47. And the 12x's will stay the same. Right? So that's going to be it. That's a little compact. Sorry about that. I'll be better as I go on. But yeah, so really, guys, all this process is going to be, I'll kind of sum it up for you over here. I'm kind of glad I left a little bit of room because I'm going to sum it up for you, right? So really all that's happening over here is you have step 1. You're just, actually, let me change this color up a little bit. Let's go with green because I haven't used green yet. So step 1, you're just going to find a common denominator. Right, so you're just going to find a common denominator. Least common denominator would be, the most efficient, but you can find any common denominator. When you find that common denominator, then you just add, subtract, right? Add, subtract the numerator, and then you just simplify as needed. In this case, we didn't need to simplify, but we will later on. We will definitely need to simplify later on. So that's it. All right, find common denominator, apply it by multiplying whatever you need to get that common denominator. Once you do that, you just add, subtract the top, and then you're going to simplify after that. In this case, like I said, we didn't need to simplify, but we will in the future. So let's move on. All right, first things first, I need that common denominator for number 2. I need it. Right? That's always what we're going to be needing. So, common denominator here. So whenever you got something like this, two binomials that do not match, there's never going to be a way for you to multiply x plus 2 by anything in order to make it x minus 1, or vice versa. You can't multiply anything times x minus 1 to get x plus 2. So what you're going to do here when you've got two binomials like this is you're going to multiply by the opposite. You're going to multiply one fraction by the opposite denominator, meaning this fraction's got to be multiplied by the other denominator, which is x minus 1 over x minus 1, and vice versa, right? So you've got to multiply this fraction times the opposite denominator, which is x plus 2 over x plus 2. Right, so that's what you're going to have. That's what you're going to have. So this blue one here, you are going to multiply 5x times x minus 1, or x minus 1, right? X minus 1 times 5x. So what you're going to get here, let's do it, right? So we have 5x times x minus 1, and the denominator is just going to be x minus 1 times x plus 2. Right, but we're going to actually need to distribute this top one. We're going to need to distribute it. 5x times x minus 1. Got to distribute that. So this has got to go here, and it's got to go here. So what I'm really going to have here, and I'm going to write it underneath it, is going to be 5x squared minus 5x. And that's all going to be over x minus 1 over x plus 2, right? And that I'm not going to distribute. I'm not going to distribute the denominator because it's in its simplest form, and then that's exactly what I want it to be. But this numerator, I've got to get simplified down to each term so that when I subtract later, I'm going to be able to do so, right? So then, my red one here, 2x times x plus 2, it's going to be the same process, guys. I'm just going to put that, and the denominator is going to be x minus 1 times x plus 2. Notice these denominators are now the same. That's exactly what we wanted. Then I've got to distribute this 2x to there and to there. So I've got 2x squared plus 4x. Plus 4x. And then the denominator stays the same. Oops, there we go. So there you have it, right? Now we can sit here, and now the denominators match, which we said earlier. So now I can sit here and subtract these numerators. Right, so let's go with black. We'll just stay with black. So now I can subtract, right? So now I can subtract like terms. So this is going to equal, let's take these like terms. Let's take this 5x squared minus 2x squared. That's going to be 3x squared, right? And then negative 5x minus 4x, that's going to give me negative 9x, right? And then the denominators will obviously stay the same. Right? And then that's going to be perfect. That's going to be just fine with me. Now, some of you might be wanting to simplify this more, which I very much can. I can take out a 3x from both, right? So if I did that, I would have, this is going to equal 3x x minus 3 over x minus 1 x plus 2. Now that's fine too. That works perfectly too if you want to simplify it one more time. But I'm satisfied with either of these, right? Either of these are going to work, so that's perfectly fine, right? Perfectly fine. Moving on, right, to number 3. This one's going to be kind of a little bit more like the end of Tuesday's video, right? This denominator, right? So I have, let's zoom in a little bit here. So I have x squared minus 4x minus 45, and I have an x plus 5. Right, so let's simplify that. Let's simplify this guy right here so that we can have a better understanding of what maybe we can multiply x plus 5 by to get equal to that. Right, so if I factored this out, my factors are going to be a negative 9 and a positive 5. So that's exactly what I have. I have x plus 5, and I have x minus 9. Now you have a better understanding. Well, I could just multiply this x plus 5 over here by this missing x minus 9 in order to make these the same, right? So if I multiply this by x minus 9, it will equal this, right? Simple enough. So let's do that, right? So let's multiply this whole fraction by x minus 9 over x minus 9. So what happens here is you just have 4 times x minus 9, which is exactly that. Uh-oh, I don't know how that happened. let's get back to red here. So I've got 4 times x minus 9, which I'm going to distribute here in a second. And this bottom's going to look like this, x plus 5 times x minus 9. Now you see that this denominator is going to be the same thing as this denominator now, right? We've got a common denominator. We didn't have to multiply this fraction by anything. All we had to do is multiply this fraction to catch it up to this one, right? We just had to say, we just boost this one a little bit to make it look like this one, and that's it. So real quick, let me just distribute this 4 so that I can combine it with the other numerator later. So I'm going to have, let's scoot down a little bit. So I'm going to have 4x minus 32. Nope, no, it's not 32. Sorry, 36. Silly mistake. And that's going to be over x plus 5 over x minus 9. Right? So now I just bring down the other fraction. I didn't alter it at all. I didn't have to alter it at all. So I've just got 10 over x plus 5 x minus 9. And I know that looks like a s. Sorry, that's a 5. Okay, then I can combine. Well, 10 plus 4x minus 36, that's just going to get me, sorry, let me change colors here. That's just going to get me, well, the 4x I can't do anything with because I can't combine it with anything. But the 10 and the negative 36 I can. So I can say 4x minus 26 all over x plus 5 times x minus 9. Now again, we can definitely simplify that a little bit, right? We can definitely simplify that. So I can take out a 2, right? I can take out a 2. So I'm going to take that 2 out, and I'm going to say what's left is 2x minus 13, and the denominator is unchanged. And that's as simple as it gets. Nothing's going to cancel out here. It works out very perfectly, right? So either of these two are just fine. Answer 1 or answer 2 is going to be just fine, oops, with us, because it doesn't simplify. It doesn't end up simplifying at all. So you can just leave it like that, right? Very nice. Coming down here, now it's a little bit of a doozy. So this one can take just a little, this one can throw you for a loop just a little bit. Let's get to it. So these denominators, there's 3 now. So it's going to be a little bit different, and I'm going to try to simplify this as much as I can. So what we have is, we have one denominator that is x plus 2. So actually, I'm going to colorize this a little bit. So I've got a denominator that is x plus 2, and I've got a denominator that is just x, and I've got a denominator that is 2x plus 1. Now, the only way to get a common multiple of all 3 of these guys, the tell-all way is just to multiply them all. So basically the least common multiple, I'm just going to say, is going to be all of them multiplied together. Just like that, right? So you need them to be all together. Now, we are going to color code these fractions, right? So this is our red fraction, as probably most of you can see. This one's going to be our, this one's going to be our blue fraction, and this one's going to be our green fraction. Green fraction. Right, so the red fraction has a denominator of x plus 2. Now, what do I got to multiply x plus 2 by to get it to look like this? Well, obviously, you got to multiply it by the green and the blue. Got to multiply it by x and 2x plus 1. So that's what we're going to do. And unfortunately, that's going to be kind of a lot, right? It's going to be kind of a lot. So basically, I've got to take this guy and multiply it. Actually, we are going to start rewriting them now. So we've got to take this fraction, x plus 6 over x plus 2, and we've got to multiply it by the other 2. We've got to multiply it by x over x, and we've got to multiply it by the green one, 2x plus 1 over 2x plus 1. We've got to multiply it by all 3 of these, right? We've got to, or not all 3, all 2 of these, sorry, both of these. Right, so what I'm going to end up with here for my red fraction is going to be this x plus 6 times x, times 2x plus 1. And that's all going to be over this common denominator that is here, right? X plus 2 times x times 2x plus 1. All denominators should come out to that. So that's exactly what happens, right? I've got x plus 2 times x times 2x plus 1 on the bottom, right? That's my new fraction. That's my new red fraction. Now, I'm going to have to combine these, unfortunately, right? I'm going to have to combine all of those, which we're going to do at the end, right? We're going to do that at the end. So let's move on to the blue function, or the blue fraction. So 4 over x, right? 4 over x. So let's get to blue here. So I've got 4 over x, and I've got to multiply that by the other 2. I've got to multiply by the red, x plus 2 denominator, and the green denominator, 2x plus 1. So that's exactly what I've got to do. So I go to red, I've got to multiply by x plus 2 over x plus 2, 2. And then I've got to multiply that by the green, 2x plus 1 over 2x plus 1. Again, we multiply both the top and the bottom. So what we're going to end up with is, right, we're going to end up with a 4 times x plus 2 times 2x plus 1 over that common denominator that we've been seeking, x plus 2, x, and 2x plus 1. Right, that common denominator. As you see, this denominator is the same as this denominator, right? The numerators are going to change, but that's okay. And again, we're going to multiply all this out here later once we see that we have all common denominators. So now we can come down to the green fraction, which is 3x over 2x plus 1. So when I come down here, I've got the green 3x over 2x plus 1. But now I've got to multiply it by the red denominator and the blue denominator. So the red denominator is x plus 2 over x plus 2. And then the blue denominator is x, so I've got to multiply by x over x. And then we see what we get. So the top, we just get 3x times x plus 2 times x, and the bottom we get our desired denominator of x plus 2 times x times 2x plus 1. So all these denominators are the same, and we can start working on multiplying these numerators out so that we can combine them. Now this is a lot of, like I said, this is going to be a doozy, right? But it's not that it's difficult. It's just time consuming, right? So just to save a little bit of time, I'm going to actually just tell you what these numerators will equate to. If you were to FOIL these, x plus 6 and 2x plus 1, you should get 2x squared plus 13x plus 6, and then you multiply that x by it all. So this final one should be 2x cubed plus 13x squared plus 6x. And of course, the denominator is not going to change at all. So x plus 2 times x times 2x plus 1. Oh my goodness, plus 1. Right? My pen is giving out on me. Sorry, guys. So there you have that one. Then the blue one is going to simplify too. Again, you've got to FOIL these two, x plus 2 and 2x plus 1. That will give you 2x squared plus 5x plus 2. Then you got to multiply that 4 by everything. So you're going to end up with an 8x squared plus 20x plus 8. And of course, the denominator again is going to stay the same. So x plus 2, sorry, my pen keeps giving out. I think it's dying or something. Yeah, it's messing up. Sorry, guys. X, and then 2x plus 1. I've got to write a little bit slower. And then the green equation, that one's actually really easy to compute. 3x times x is 3x squared. And then you just distribute the 3x squared to the x plus 2. And that's just going to give you 3x cubed plus 6x squared. And of course, again, guys, that's going to be over the same denominator, x plus 2 times x times 2x plus 1. Then, guys, we've got to add all of that up. We've got to add all. So like I said, this is going to be really tedious, really time-consuming, going to be a doozy, right? But it's not that it's hard, just time-consuming. So what we're going to do here is I'm going to actually leave it like that. You can rewrite it if you want, but let's just leave it and combine like terms, right? Because this is all addition up here. That's an addition sign, that's an addition sign. So we're just going to combine all like terms on the top. So how many x cubes do I have? Well, I have this one and I have this one. So let's combine those. 2x cubed plus 3x cubed is going to be, let's come down here, is going to be 5x. Then I've got to get the next term, right? So the next term are these x squareds. So 13x squared. Actually, let's grab a different color just so, hang on just a second, just so we're not confusing. Let's do green. So these x squared terms, 13x squared, 8x squared, and 6x squared, right? Those all combine. Those are all positive, so you just combine them. So what I'm going to get there is a 27x squared. And then I have a 6x and a 20x. Combine those to be 26x. And finally, I've just got that 8 straggling out there. And then that's all going to be over that common denominator of x plus 2, x, and 2x plus 1. So there you have it. Again, guys, yes, it was a lot of work, but it's not difficult, just tedious, right? So just a quick little rundown of it all. Again, you just got to find common denominators, add, subtract, and simplify. Really, it's as simple as that, guys. The only one that really was a doozy, really ugly, was this 3-term one up here. Let me erase that so you can see it. This 3-term one is going to be kind of a little bit, but not so much that it's hard, just tedious, right? So good luck on your homework, guys. Again, if you need us, we're available for tutoring. Just contact your teacher or look at that tutoring schedule to join whenever you'd like. Okay. Hope you guys have a great rest of your day.